This is Algebra 1, Lesson 5-6. Today is January 17th, and today is a snow day or a digital day. So you are listening to these notes at home. If you have a printer or some way to take the notes, then you're going to take them with me. If not, you need to take these notes on your own time, after school, during any free time. All right, so 5-6, point, slope, and standard form. We've already learned one form, slope-intercept form. We're going to learn two more today. So what is slope-intercept form? Pause the video, write down what slope-intercept form is. All right, you've unpaused the video. Y equals to mx plus b. And let's go ahead and label what we know. We know that m, this guy right here, is our slope. And b is our, you should be thinking, yeah, that's right, y-intercept. So point-slope form is very, very similar to slope-intercept form. The main difference is like they change the symbols around, and instead of having a y-intercept, they just choose a random point. Anywhere on that line, a random point, and then you still have the slope. And that's why it's point-slope versus slope-intercept. This one has an intercept, this one is just a point. You can even tell by the name. So what does point-slope form look like? And it's something that you are going to have to use, especially if you ever go into calculus, especially AP calculus. You'll be using this more than any of these other three forms. So it's y, just like we start here, but instead of having everything on the right-hand side, we're going to put one term on the left-hand side, y minus y1. I'm going to come back and talk about what y1 is in a sec, but let's go ahead and copy down the rest of the formula. Y minus y1 is equal to m times the quantity, so start your parentheses, x minus x1. All right, well, m is slope. Slope applies to these two m's. We're done with slope. We know that m represents slope. Our new things, let me box these in green, x1 and y1. And notice that there's always a minus sign in front of them. So if you see a positive sign, that means you had a double negative. But that's kind of not super important right now. We need to know what are x1 and y1. Well, if I have a point, my point is always in the form of x comma y. X comma y like this. So something x comma y. So whatever that point is, treat the x coordinate as x1 and the y coordinate as y1. So if my point was 1, 2, then I put 2 in for this green box and 1 in for this green box. And we'll be talking about that in example 1 shortly. But let me talk about standard form also before we jump into the notes. I'm trying to teach you everything right up front. So standard form. Standard form is, it looks like this. So you have ax plus by is equal to c. And I do capital A, B, and C so we can distinguish those from our normal x and y's. Like all of our forms before, we have an x and y. Now we have these three numbers, A, B, and C, and here's something specific. A, B, and C are integers. And again, integers is a fancy way of saying whole numbers. So integer, that's like a number like -7, 3, 100. Those are all integers. Things that are not integers, 1.2, that's not an integer, or pi, that's not an integer. It has to be a whole number. So A, B, and C are whole numbers. They are integers, and it follows that form. That's all there is to standard form, and we'll be playing with standard form on the back side of the paper, I believe. So we do that. Okay, then we start doing standard form here in example 3. But example 1 and 2 are playing with point-slope form, and these are very similar to the problems that you'll see on Khan Academy as well. So example 1, complete the slope or the point-slope equation of the line through these 2 points, -2, 7, and 1, -2. Okay, so we need to have a point and we need to have a slope. It looks like they're choosing one of these points, and maybe you can see which point that is because they're already saying I'm going to subtract 7. It doesn't matter which point it is for now. I mean, eventually we'll have to figure it out, but right now I want to figure out the slope. Just like we have to do for slope-intercept form, you need to find that slope. M, slope, and then instead of saying M, I'm going to say slope. The definition of slope is, you should know this, definition of slope is delta y over delta x. The change in y over the change in x. All right, so I'm going to choose the second point minus the first point. So this -2, that's the y coordinate, and I'm going to subtract this 7. So minus 2 minus 7, and then the denominator is my change in x, my delta x, so it's 1 minus a negative 2, 1 minus a negative 2. All right, let's calculate what that is. Let's simplify this fraction. I'm going to add the opposite for the numerator and negatives kiss on the denominator, so I have negative 2 plus a negative 7, which is a negative 9, and 1 plus 2 is a 3. Simplifying negative 9 over 3, that turns into a negative 3. So I know my slope. My slope is negative 3. If I come back up here and look at point slope form, I know that I'm going to do y minus the y coordinate of whatever point I'm looking at. Okay, well, I did y minus 7. Where do I see 7 in a point? I see 7 right here. That means I'm using this first point when I'm doing my equation. So disregard the second point from now. I'm just dealing with the first point. So the next thing that I have to write the slope, the m. Well, I found the slope. The slope is negative 3. So I'm going to write that negative 3. And then I need parentheses. So start my parentheses. I always will have an x here. Always an x here. I will always have a minus sign here. I will always have a minus sign here. And now I need to do the x coordinate of whatever point. Again, I'm dealing with the first point, so the x coordinate of the first point is negative 2. I substitute in negative 2, and there's my equation. Of course, I have double negatives here. Hey, bud. I have double negatives here, which means negatives kiss, and they become positive. All right, so that is the full answer for example 1. Go ahead and box it. That is our answer. All right. And on to example 2, which is the same type of problem. So complete the point slope equation of this line, and it's going through these 2 points. All right, I can already tell which point they're starting to use. Luckily, they gave us parentheses around it instead of just making it a positive. They could have just said y plus 3 here. So they're using the point negative 3. So which of these points are they using? That's right, they're using the first point again. They could have used the second point. It doesn't matter if you use the first point or the second point. Either will work. So in this case, they're using the first point. Let's go ahead and find the slope because that's the next value that I need to fill in for my equation. So, got some weird lag things that are happening. There we go. So slope. We know the definition. We've been writing it over and over for this whole unit. Slope is the delta y over the delta x. All right, the change in y. So that's the 3 and the negative 3. So this is going to be 3 minus negative 3. And that's all going to be divided by, again, second point minus first point. So 13 minus 5. 13 minus 5. We have negatives kissing, which makes it a positive. So 3 plus 3 is a 6. And 13 minus 5 is 8. This is a fraction that can be reduced. 6 over 8. We can divide the top and bottom by 2 to reduce this to 3/4. So our slope is 3/4. Let's go ahead and fill that in for our equation. 3/4. And then let's see what to do next. So once you write the slope, then you do parentheses x minus the x coordinate. So then I write the parentheses. I say x minus the x coordinate. The x coordinate of the first point again. So the x coordinate is going to be 5. And there's my final answer. Again, since I have double negatives, this could be just y plus 3 here. And box your answer. There's your final answer. All right, now we're on to example 3. Example 3 is using standard form. And it's not writing the equation. Standard form for the homework tonight is being able to graph from standard form. And standard form is pretty cool because the way that you graph it is by finding the x and y intercepts. And I'll show you what I mean by that. So first of all, it is in standard form because I have a number, a whole number, which is negative 3, and a whole number. And that does match this form. A whole number in front of the x, whole number in front of the y is equal to some number on the right-hand side. We can see it does clearly match its standard form. Once you see standard form, you should be thinking x and y intercepts. And I put a little table here on the back. Once you see standard form, you're going to plot the y-intercept, plot the x-intercept, and then, of course, graph the line with arrows. Here are all the steps for graphing for each of those different forms. So let's go ahead and find the x-intercept first. It doesn't matter if you find the x or y-intercept first. You just need to find both of them. So, finding x-intercept. This is some good review. What do I need to set equal to 0 in order to find the x-intercept? Pause the video now, think about it, come up with an answer. All right, you've unpaused the video now. So to find the x-intercept, that means the y is set equal to 0. There are two ways to remember this. You can either think of the opposite, so x-intercept, so opposite of x is y, and set that equal to 0. Or you can think about it as if I set the y equal to 0, it will get rid of the y, and I'll be able to find the information that I need, which is the x, because I'm looking for the x-intercept. So by setting y equal to 0, I'm going to rewrite this equation. So it's going to be 2x, and maybe I should switch up colors here. It's going to be 2x minus 3, and then instead of y, I'm substituting in a 0, and that's going to be equal to 6. Well, 3 times 0, that's just 0, so that term goes away, and I'm just left with 2x is equal to 6. 2x is equal to 6. And I'm running out of room, so I'm just going to write the answer on the right-hand side here. When I divide the left and right by 2 to get the 2 to go away in front of the x, I'm going to get x is equal to 3. So let's write that here. That means x is equal to 3. Cool. That is the x-intercept. The x-intercept is 3, 0. So I'm going to go out on the x-axis. 1, 2, 3 in the positive direction. There is my x-intercept, a nice big point. All right, the next step is to graph the y-intercept. Y-intercept. All right, you should know this just by looking at the x-intercept, but what do I set equal to 0 for the y-intercept? Pause the video now, think about it. You've unpaused the video, so the y-intercept is where x is equal to 0. It's, again, the opposite, or trying to cancel out the one that we don't want to find the one that we do want. When I do that, I'm going to substitute in x, so I'm going to have 2 times a quantity of 0 now. I'm just rewriting this equation, minus 3y. That's going to be equal to 6. All right, 2 times 0 is just 0. Don't worry about that term. And now I have negative 3y is equal to 6. So I need to divide both sides by negative 3. So divide both sides by negative 3, negative 3, negative 3 to get those negative 3's to cancel out. And I'm just left with y is equal to 6 divided by negative 3. Well, a positive divided by a negative is a negative, and 6 divided by 3 is 2, so it's a negative 2. All right, graph y is equal to negative 2. Well, not necessarily the line, but the y-intercept. The y-intercept is down here, y equals negative 2. And we have 2 points. Whenever you have 2 points, make a line, make sure that you don't remember, or that you don't forget your arrows. So come over here, and I make a line that goes through those points, and it should continue on where it goes. So of course I could just do a line that looks like that, but in order to extend the line, I know that I'm going left 1, 2, 3, down 2, left 1, 2, 3, down 2. So it actually goes through this point as well, and continues going on. And for some reason that green dot went away, so I'll put that back on. And of course, don't forget your arrows. All right, and there it is. Let's do one more example on the back. So let's graph this one. Again, it's in standard form because we have a number with the x and y's on the left-hand side and one number on the right-hand side. So it's in standard form. Let's go ahead and find the x-intercept. The x-intercept. All right, to find the x-intercept, what do I set equal to 0? Pause the video now, think about it. And you have answered y is equal to 0. So y is equal to 0, I'm going to sub in y equals 0, and there is a shortcut for this. If y is equal to 0, I know this whole thing is going to be gone because 4 times 0 is nothing. So I'm just immediately now taking the shortcut and saying it's going to be negative 3x is equal to 12. This 4y term went away because when I sub in 0, 4 times 0 is 0. All right, from here I'm going to divide both sides by negative 3. Divide by negative 3, divide by negative 3, and then the negative 3's will cancel out, and I'm left with x is equal to negative 4. All right, let's graph x equals negative 4. Again, it's x, so it's on this x-axis, and I go left 4. 1, 2, 3, 4. That is the x-intercept, negative 4, 0. Now that we found the x-intercept, let's find the y-intercept. Y-intercept. What am I setting equal to 0? That's right, the x, because you're doing the opposite, or you're eliminating the thing that you don't want to find the thing that you do want, which is the y. If x is equal to 0, that means this whole term right here, this whole term right here goes away, and I'm just left with 4y is equal to 12. That's the shortcut here. So the shortcut, 4y is equal to 12, because all the x term went away because the x term is 0. So from here, I need to solve for y. Solve for y by dividing both sides by 4. The 4 cancels out, and I'm left with y is equal to 12 divided by 4, which is 3. Got lag, 3. So graph y is equal to 3, go up 1, 2, 3. There's my point, and go ahead and make a line through those points. And of course, don't forget your arrows. All right. So again, I have this table for steps for graphing. Slope-intercept form, we know how to do that. You have y equals mx plus b. You plot the y-intercept first, and then you use the slope to graph the second point, knowing that the slope is, you go right by the bottom amount. So if you have your slope is delta x on the bottom, delta y on the top. You use the slope to say you go right this amount, and then you go up or down this amount. That's what I mean by using the slope for the second point. Point slope form, I'm not really going to quiz you on how to graph, but it's the same thing as slope-intercept form. Instead of graphing the y-intercept first, you plot the point first using your x1 and y1 term, and then you use the slope for the second point, just like you did with slope-intercept form. For standard form, you plot the y-intercept and x-intercept just as we did above, and the third step is the same, graph the line with arrows between those 2 points. All right, that's all I have for the notes today. Go ahead and write your summary if you have the notes. And if you're just watching, now is the time that you can switch over to Khan Academy. The Khan Academy assignment is going to be due tomorrow, Friday, January 18th. I will be checking for that. All right, thanks.